Hello, my name's Peter. I'm here to talk about Chalk and Talk. Is it twice? Yeah. So I'm doing the PGCHE, and as part of this, I was to observe an experienced lecturer teach, and he taught by scribbling on a board, and the students copied it down. And one of the questions he asked at the end was, would the use of OHP slides or PowerPoint improve the session? So this is what I wrote my essay. Chalk and talk is what you say when the lecturer writes on the board and talks through the material, but often it's a whiteboard, so there's no chalk. Teaching by chalk and talk is seen as old-fashioned in many subjects, but it's often used in mathematics still. And is that a good idea? So, I reckon there are three types of lecturing. You could do only chalk and talk, which I'm calling completely live, everything's done live, which is how I was taught when I was an undergraduate. They wrote on the blackboard and you copied it down. Or no chalk and talk, so everything's wholly prepared, so it's all PowerPoint slides, or a combination of the two. So, let's have a look at those. The completely live is where everything's written on the board and you copy it down, which it's good for the student to do some writing of the mathematics. And it genuinely is. If they only ever see written mathematics, they start to have to actually draw an X, and they go, the X's when they're on screen look like this, and I've got to draw it like this, and just silly things like that. They don't know how to write an equal sign or an ampersand or whatever it is. So they get the practice, but you end up writing a large amount of text in between the mathematics, which, I mean, this is, my experience was big lecture theatres at Nottingham University. The text would disappear up towards the top, and you're writing the bit from the top board as he rolls up and starts on the next one. You spend your whole time running to catch up and not actually taking in what's there. Right, this chap Wakely, if I pronounce it right, there's a few names in here, I realise is a student who's written in the Higher Education Academy Subject Centre Connections newsletter, and he thinks that chalk and talk is quite outdated, and he notices some of the pressures within the university on that method. So he's noticing his lecturers being told they shouldn't be using chalk and talk, they should be using more modern things. But he feels that seeing mathematics live is vital. And
I think in maths that is an important point, because that's actually doing the maths.
Because you're actually practicing doing it. So he wants a live demonstration of mathematics. I like this one. Involving a living, breathing mathematician explaining the problem using the piece of chalk as an extension of their mind to bring the solution to life. To see mathematics being done live in front of you will often bring insights to the massive symbols that appear on a printed page. I think that's very important. Just handing out notes, he doesn't see it, but when it's written out, he brings it to life. The lecturer somehow provides a light through the printed algebra to the deeper method and the understanding which underpins mathematical thinking. Try and get rid of that. Right, here's one I'm not sure about pronouncing. Dinverno?
Sounds good, yeah.
Discusses, he talks about various ways that he's tried to lecture over the years, so he's writing from an experienced lecturer point of view. And he thinks it's a weak technique completely live. It's somewhat redundant and frustrating process, which is what I'm saying about copying down all the words and the words are vanishing off the ceiling. And he says it's no wonder that students complain the lectures were boring, because all you're doing is copying out text. That didn't change. There we go. So the wholly pre-prepared method. So you teach from OHP or PowerPoint, which is more normal than other subjects, I think. Can give structure to the lecture and help control the timing, so you keep on track, you don't ramble off into other areas because you've decided to get interested in something, but it can be too polished. So Byrne discusses the differences. Yes, I can pronounce that one. Is writing about mathematical thinking, and he discusses the difference between the way mathematical ideas are formed and the way those ideas are later formalised and published, which I think is very interesting, because mathematics is often, here's the theorem, here's the proof of that theorem, and it isn't showing you how it's done, it isn't taking you through the calculation or what have you. So the student isn't quite, they're only seeing the end result, they aren't seeing the process in the meantime. Dreyfus warns the students, similarly, student may lack the working methodology of the mathematician, the know-how that allows them to use their knowledge in a flexible manner, so apply it to other situations. And actually, the session I observed, the chap made an error. And on the next line he realised that error, and he went back and changed it and sorted it out and carried on. And I think that's very powerful, because the students have seen, here's how you recover from an error like that. You notice it, it's obvious it's an error a couple of lines later, and you go back and go through and change it. So I think that's being a bit flexible and playing around with it, which you wouldn't necessarily get from PowerPoint, because it's so polished, it's absolutely right, and everything's perfect as you go through it.
Absolutely right.
Well,
you can't correct it on the way, though.
No,
no, quite. They've been taught the products of the activity of scores of mathematicians in their final form, but they have not gained insight into the processes that have led mathematicians to create these products. Right. D'inverno again has tried this method and reports the worst weakness was because the students did little writing, they became bored or distracted. So when they're writing everything, they're bored because they're writing everything, and when they're not writing anything, they're not listening. Dreyfus cautions a serious disadvantage in this process, inflexibility in adapting to the students, which is what we just said. If they ask you something or something's slightly wrong on the slide, tough. Can't do anything about it. Baxter is a new lecturer. I think he's writing after his first year of lecturing. Tried teaching from pre-prepared slides, but reports with ready prepared slides it's all too easy to rush through the material, which is interesting because a lot of people will say PowerPoint will help you timing, but he found he was rushing through too quick for the students, leaving the audience confused. Writing notes on the board gives a natural rhythm to the lecture that prepared slides do not, and I've heard that from quite a few mathematicians, that they find the action of actually writing it out keeps them to time and keeps them at the rate that the students can follow what's going on rather than just...
That's the crucial bit. You can't.
Doing this and keeps moving through it. So I think that's very interesting. So, part live, part pre-prepared. So, we've decided it's advantageous for students to see mathematics perform live. And this Wakely, the student describes it as someone working at a chalkboard ready for battle, armed with a sharp mind and a stick of chalk. Very poetic. However, we need to avoid this redundant and frustrating process of copying down large quantities of text. So doing a bit of both sort of taps into the advantages of both, hopefully. So, lecture notes might be given out that are incomplete, and you've got gaps that the students fill in as you write on the board. And I did have a couple of lectures like that. Or, the lecturer might also use incomplete notes on an OHP slide or whatever and fill them in as he goes along. Or, you're giving out complete notes, but there are extra examples that you go through in class that you don't give out, and the students have to copy down. D'inverno believes it is important for students to do some writing of mathematics. I think that's very important, as I said earlier. He wants them to develop what he calls a tactile familiarity with mathematics simply by shuffling the symbols around, which is a necessary skill, I think, because if you've only ever seen it on a computer screen and then you come to actually do the problems, you don't necessarily know how to, or you're not familiar with the symbols sufficiently. He used incomplete printed notes to allow students to shuffle the mathematical symbols while getting rid of the redundant process of copying down text. So all the connecting text was there and the students just have to fill in bits of the mathematics, which happened when I was at university. I think it might have something to do as well with how hard it is to put mathematics into a computer. Baxter, the new lecturer, found that while he thought... so he thought adding detail and explanation would aid understanding, but he found that too much detail could be distracting in his notes that he was going through, and he needed to strip it down to the bare essentials for the lecture. So giving the extra detail in a pre-prepared handout and going through what he considers to be the bare essentials on the board might have helped there, I think. Accessibility. I was going to say I've got one slide on accessibility, I think there's another one in a bit. So, the live demonstration of mathematics is awful for accessibility. Because if you can't see the board or you can't hear me, or you're lip reading me and I keep turning to the board to write on it, you've had it. So, how do you deal with this? I mean, it's a difficult thing. It's difficult for PowerPoint as well as for Chalk and Talk for mathematics. Because PowerPoint with maths in it isn't necessarily very easy to convert to Braille either. But certainly if I write something on the board, it's lost and nobody's ever had any access to it. So, printed handouts, and I put in a suitable format in advance of the lecture to those students who need them, can help. So if I'm going to go through a lot of examples on the board, if I can give those examples to somebody in Braille beforehand, they can try and follow through. The problem with that is that it keeps me to what I've planned in advance, and that adds some inflexibility. But that's probably a good solution as any if you're going to do writing on the board. And since writing on the board is such an advantage to the majority, you have to do something about the minority. You either need to tutor them separately, or you need to give them something to follow in the lectures. The worst case is that you don't give them anything to follow in the lectures, and they just sit there and have no idea what's happening, and then 2 weeks later someone's typed up the notes for them. And you know, how on earth are you going to follow a course that way? So, it's always been a problem that students with visual impairments or dyslexia may not be able to access the chalk, and students with hearing impairments may not be able to access the talk, if you're going to chalk and talk. So, we look at what can we do, can we try and aid this at all, and we come to interactive whiteboards. Replaces the projection scheme, here it is. It's a touchscreen interface to a computer. Any content which can be displayed through a projector can be displayed on the interactive whiteboard, and touching the screen replaces the mouse. And some people seem to have conceptual problems with how do you use one. And it is just when you press, that's what you click, where you would click the mouse, and what gets displayed is what would get displayed if I were doing it over here. So I think it's fairly intuitive once you've perhaps got used to it a little bit. Having said, which we'll see in a little bit, how used to it I am, because I just had a bit of a practice at something later on and I can't quite get my finger to do it right. But anyway, I think it takes a bit of practice, but you can get used to it. And then pens can be used to write on the board. So I've written on the board in pen, and then I can rub it off. And it's all simulated on screen. This is not a real pen. So, and the different colour pens, basically if you pick up a green pen and draw on your finger, it goes green. And if you put the pens in the wrong slot, whichever slot is absent is the colour that appears on the board. Right. Oh yes, and the board can be used as a traditional whiteboard, so let me get rid of that. The other thing that you can do with this is, in PowerPoint, if you press W, you get a white screen. So you could just put this up and start writing on the board. But the point about the interactive whiteboard is it can record it.
Oh, that's
so I could just use it like I would use a normal whiteboard, and it could be being recorded so that somebody could play it back later.
And what's it saved as?
Various things. You can save still image. I mean, I can just save the images into the PowerPoint, or you can record it as a video. Various formats, various video formats. Right. When I close it, it'll say, "Do you want to save your figure to the PowerPoint file?"
And then you could choose the format.
For videoing it as it's happening, you need to have set it up beforehand,
Right.
which I haven't.
But otherwise,
But at the end, it will say, "Would you like to save your figure that you've drawn?" And I'll go no, but I could go yes and save it.
And then incorporate it into the PowerPoint like that.
Yes, although if you're doing it for a watching live mathematics demonstration, you really need to be recording it as a video, because just giving everyone the stills is fun. Okay, so Starkings and Krauss, do you think?
Oh, sounds good, yeah.
Call this a new type of chalk and talk. So they write an article on how they used it at London South Bank University, and they report a favourable initial reaction to this method by the students. So they got some funding, they got some of these, and had a go with them. Right, so this would allow pre-prepared, incomplete lecture slides to be annotated as one would normally write on a board. So this is sort of like your partially completed OHP slides that you're filling in, only you're using PowerPoint, so you're keeping everybody happy, and you can record it later on. You can record it as images or video, and I've put this could aid some accessibility issues and allow access to the live content for students who wish to revise the lecture at a later date. So I met a chap at a conference who'd been doing this, and he was recording his lecture, chopping it up into topics and putting those topics online, and then students who want to revise, you know, they might, I think it's not uncommon for a student to think, oh, I really understood that in the class, and now I can't remember it. When he explained it, I really understood it, so they could watch the explanation again. You need to record the audio, of course. The image of the stored writing can be enlarged. Right, so mathematics is difficult for OCR. So if I scrawl some mathematics on the board, we save it, you still can't make that in Braille. But you can zoom in on it and have a look at it if that will help you, or you can look back at it slower. If you have a visual perceptual difficulty, you can pause it and study it a bit longer. So it helps some people, but I mean, it won't help everybody. There are some people you can't, writing just isn't good enough for. Oh, tablet PCs are very similar to interactive whiteboards. At Nottingham Trent, at least, they use the same software. And what that is, it uses the normal size screen over here with a pen, and you just write on the pen. It's more like normal writing, rather than writing on a board, which is possibly an advantage. It's more like annotating OHP slides than it is writing on a whiteboard. It's sort of analogous to that. One thing this chap at the conference that I met said is you can face the audience at all times, which is quite important if you've got a lapel microphone, because if I'm talking to you and it's recording it, and then I turn to the board, there's an echo. And he said he found that when he was trying it with an interactive whiteboard, the recording would suddenly get a lot louder when he turns towards the board because there's this echo. And I thought that's very interesting, whereas you can be stood over here and you're writing and you're watching the class and you're making sure they're paying attention and everything's appearing there and you're seeing it in front of you, and I think that might be also, I think it might be better for some people anyway. Here, they've told me that when they're installing new lecture theatres, they're putting in this touchscreen monitor. So a lot of them have it. The John Clare lecture theatres have it. It's also better for lip reading facing the audience, which I'm not doing very well. It's perhaps more difficult to get the students to contribute, because they've got to then come and write on your lectern rather than writing on the board. Okay. As part of the PGCHE, I had to do this micro teaching session, which is a 15-minute session on some course material to my course mates. It had to be something from my teaching that had to be understandable to my course mates, not only the mathematicians. So it was a bit of a strange brief. So I gave a piece on infinity because I was teaching introductory integration, and I gave a bit on summing infinite series, basically. I used the interactive whiteboard because it was in this building and they had an interactive whiteboard, and this is one of the slides that I had. So adding an infinite number of things, this idea that adding an infinite number of things can add up to a finite number is demonstrated thus. You say, well, take half of it, and then add half again, and half again, oh dear, half again, that's because I brushed my hand with this. Half again, half again, half again, half again. And you can keep adding halves to infinity, and you get the whole, and you don't get off to infinity. So this is, that's the recording of the slide I did on the day. Okay, so it's adding an infinite sequence that doesn't, so that's one method, that if I just displayed that graph, that chart, that picture, that they may not have understood, and then you get into doing some complex animation to make it all appear in the right order, whereas actually I've just scrolled it on the board. And at the end of it, I was supposed to do a survey of the people in the room and see what they thought of it. We had a bit of a chat. They were quite enthusiastic. Most felt it was a rubbish. One person felt the technology was distracting and confusing, so that's worth remembering. Although at the time, we weren't quite sure how to use the interactive whiteboard, and I was recording each slide. You can
so
do it.
It was distracting and confusing.
Yes. As I'm still not quite sure now, but there was something about grabbing a screenshot, and then it wants you to select an area. And there must be another way of doing that, but it ended up that I had to select each slide each time I wanted to change slide, which was cumbersome. But it must be possible to record it properly. And I know now when you close the PowerPoint, it'll say, do you want to save these images as a PowerPoint file? So that's one way of doing it. Most agreed seeing the material performed live was an advantage, rather than just being given notes. Seeing the actual, and that wasn't really mathematics, but they could sort of see that if they were going to learn mathematics, they would have a go that way. But one felt, now I said this thing about the lecturer making a mistake and changing it and mucking about with it, and one of the students said, if she saw a lecturer rattle everything off without just seemingly from his head, she would get completely, there's no way I could ever do that. See, I said, the fact that he's made a mistake and corrected it makes them think, well, I could do that, I make mistakes all the time, here's how I correct that mistake. And she said, oh no, for me that would just scare me too much. This person is a genius that I can know a coffee. So that was the response from that. Right, another opportunity to try it out, I was asked to give a demo of teaching how I would teach Introduction to Matrix Algebra in 15 minutes. And that was in a room with a tablet PC, so I had to go with a tablet PC. Excerpt follows. Now, weirdly, I had a video here, and when I came to this room and put it on this computer, I tried it on about 4 different computers, it was upside down. So I inserted it again.
Show it, let's see it.
It just, I mean, how does that happen? I don't understand that.
I don't know. You know, when we had our interactive technology conference,
yeah,
one of the speakers came in and played a video, and that played upside down. If
was
you
really
tried to do it, you couldn't.
Yeah. Well, and the rotate and flip and all that were greyed out. Because I inserted it again, I took it out and inserted it again. Anyway,
Other people showed, and later on, her video showed the right way around.
Oh, okay.
Without touching any.
Perhaps I should try it again. So this is the video recording of me giving this session. I didn't record the audio because I didn't have a microphone. Matrix multiplication, do you all know? First row times the first column, first row times the second column. Now what I quite liked about this is the bit that I've just talked over, where you scroll over it, you write your values here, and then you scribble it out and start the next one. And in a normal setting, you end up with lots of trying to rub around the numbers without. Now here, because the numbers are permanent and your writing can be rubbed out, I think that's quite a nice little demonstration of it. Here it goes. You just rub over the whole lot with the board rubber or with the pen and on the touchscreen. You turn it into a rubber there and start writing on it again. And it's far less messy and very nice. I quite liked it.
Yeah, that does work really well.
And then I'm sort of aware that. I think for the first one, I've sort of underlined the 2 numbers that go here, and then I've put a line next to the 2 numbers that go here, because you've got to be aware that somebody is looking at it, they don't know where you're pointing, so you've got to try and indicate somehow this number times that number without. So it's quite strange having to moderate your language, that you're sort of saying, then you times this by this. Oh, you don't know what I'm pointing at, because you can't see me, because you're only recording the screen. Okay.
Well, that works really well, I think.
accessibility again. Does using touchscreen technology and recording lectures solve the problem? No. But it will help more students than would have been helped previously. It also allows improved access to lecture content for all students. Right, other possibilities, besides doing what you do already and recording it, doing what you do already slightly better for rubbing out of stuff, that you can also, this is a computer, you can run software. Annotation of software demonstrations, this is someone pointed out to me. You can be running Excel and you can put a circle around the bit that you want to find this menu item or whatever. You know, you can just scroll all over a piece of software, which is quite interesting. And then there is software specifically designed for interactive whiteboards. So Mark Crowley over in the Centre for Effective Learning and Science here has done some resources, and this is one of them. And this is specifically designed for classrooms using interactive whiteboards. So you would get the kids to come up, you would give them some points, and you would get them to try and draw a straight line through those points. And then once they've tried that, you can have a look at, you know, how right were they, how close were they, using different methods. You can generate new points. You can move individual points, so you could say, you know, do that, and then they can, how is it like that? They can mark one point as anomalous. Ignore that one. And then when you try and draw your straight line, it ignores that point that you've marked as an outlier, or whatever it is. So, I mean, that's very good, I think, that you can just stick to them. You can do curved lines if straight lines are not good enough. And anyway. But I mean, that's quite good in terms of audience participation, getting people up to have a play with the thing. GeoGebra. Now, in March, we had Chris Simon come and gave us a talk on GeoGebra, which is available on the Elms. Well, it will be. It's here, in fact. So it will be on the Elms website soon. If I click on that, yeah. Now, I've got a piece of paper. This is where I started to have a bit of trouble because I'm starting to click on stuff that I can't see very well. Oops. I need to do a bit of typing, which is a bit of a letdown. But I've just started from a new window. I could have started from a partly prepared one instead that already had that function on it. But anyway, so this is a function. This is one of the neat little tricks in GeoGebra I saw. The chap who developed it, Marcus, somebody, gave a talk at the MSI Network conference, and this is one of the things he showed, which was quite cool. So if I select make a new point, click the function, I get a point on that function. I then want to find the tangent to that point on that line. Bingo. I then want to, down here, find the slope at A. That shows me the slope at A. It's giving the slope at A of M as M. The advantage of this is I can now move my point A and it recalculates everything for me. If I then ask it for a point B, which has the coordinates, the x coordinate wants to be the x coordinate of A, and the y coordinate wants to be the value of M. Okay, so we're plotting the x value against the gradient. So that's B now next to A. Then as I drag A, B moves with it. And then the trick is, if you double click on B, you click show trace, which means it traces where the point has been. You see, see where I'm going? Then you trace B. And isn't that lovely? You're showing how the so I mean that's very clever, and it's very. I could have done it on a normal computer with a projector, but it's quite neat having it as something that you can just scroll all over the board.
Yeah, it looks much more impressive, doesn't it, when you're doing it with your finger.
I can see why the student would feel unsure about doing it themselves, though. You know,
yes.
Presenting that sort of thing to my students, like, oh yeah, great, you know, and then you say, right, go away and do it yourself. You know.
Yeah, well the interesting thing was Chris, when he gave his talk, well you can watch it online, but he was giving students open-ended problems and they were solving it and giving their solution using GeoGebra, but they did require some practice, I think. I think that's all I have. Oops, I've gone back. References. So, who wants to have a go?
That was great.
Ah, here you are. Would you like to add your drawing to the PowerPoint presentation? I can do, and then it'll be in there and I can save it. Yeah. Right.
It works very well, doesn't it? It really
Mm.
does. Yeah.
Mm.
There are some advantages.
So supposing you're just going back to total basics, because I've never used one of these things before. If you go into a room and you're faced with one of these things,
Yes.
and you've got your PowerPoint presentation on a pen drive or something like that,
Yeah.
what do you do to get it to appear on there rather than on the thing in the ceiling?
I just came in and it was like that.
Ha ha ha!
Some of the rooms. Oh, this is one where there's a. That's the default position, and all this is plugged in.
So you're just
It's plugged in as a new input
essentially
device.
you're not projecting from behind.
No. So if I do, for example, if I do this, you lose. I don't know if you can see behind my hand, but you lose
Yeah.
the.
Okay.
It is the projector, and all that is
Yeah,
is a
some of the
touchscreen.
rooms have actually got one that I think projects from behind in
Right,
some way.
okay.
And I don't know, some of the ones in cells I think do that. And how they
Yeah.
work, I don't
They're like huge
know.
tellies, are they, rather than...
No, but
yeah.
this, so to get it to include your drawings, obviously that's got to be turned on, and there's
The
all
software
that,
in the program that just starts this
there's
menu
all
here.
that stuff down there, yes.
That started when I started the computer up.
Yeah.
That's the recorder.
And
by the
they
way, if you
do
want to- if
usually,
you want to
don't they?
record
Where
yourself.
there is one, that
Yeah.
usually happens
Yeah.
when you start the computer up.
Yeah.
I
So
haven't
you.
used it either, but I've noticed all these.
These have various functions. Notebook
Yeah.
is screenshots that you've saved. The recorder, that's how you record it. You just click
Yeah.
record.
Shuffle it over a little bit, it's actually falling off the edge of the...
If you click record, then that will
If I click record, it now starts recording. If I then bring
record,
up,
integrate stuff that you've done into that PowerPoint presentation.
yeah. So if I now,
So there's just buttons on there.
I now just scroll it, and then if I
I think
click
it needs some
start,
experiment, because the worst thing possible with students is to try and use new technology and then discover that you don't know how to use it.
well, here's yes, absolutely. I think it does need pressing. That's the AVI I just recorded.
It doesn't look
I press
too
start.
complicated, does it?
No.
Yeah, that worked.
Mm-hmm.
You're sort of aware of how long it took you to pick up the pen and stuff when you watch the recording back over this time, but
Yeah.
I don't think you'd be going back editing them, would you, though? If
No.
you were to do that. But
so yeah, I mean that's.
Mm.
That's one way of recording it, which, I mean, it's all very simple, but I would practice. I mean, I haven't practiced a great deal. But I came in, the first time I tried to do this GeoGebra demonstration,
That's lovely software.
I've lost the point off the side of the screen. I ran like this, and then my finger went, and suddenly I was moving the graph rather than moving the point, and so but I just wasn't pressing hard
You've got
enough.
to get used to that.
Yeah, because I was a bit timid, I was just sort of
And then
running.
you were still doing it with the instructions there, weren't you?
Well, yes, that's because I'm a bit nervous. I thought I might do something
Yeah.
stupid.
You want to get that
But-
function right, don't you? So that
Yes,
you do it.
yes. Because I tried doing it just by typing in an arbitrary function. Of course, then you've got to do the scale and look it out.
Yeah,
So
yeah.
it's necessary to, I think, to think about it beforehand.
Yes, it doesn't look too.
It might be.
So press harder. Because I was a bit timid. You feel like you're going to break it, but if you don't press hard enough, it thinks you stop clicking and start
Yeah,
clicking.
as well.
You should be able to. Perhaps not. Oh no, perhaps not, because B is defined by M. Yeah.
That's cool.
You can play with it for hours, couldn't you?
Well, and then the next thing is, of course, you can draw a parabola on top of it. Actually, you can move the graph if you
Yeah.
allow me to. You can move the
Oh,
graph.
right,
So
yeah.
you can draw a parabola and try and fit it, and then once you've drawn it, what's really powerful about GeoGebra is that it links this to this. So if I drew a parabola and try and fitted it somewhere near there, and then looked at the function of it, I can say, oh, that looks an awful lot like, you know, nx to the n minus 1.
Maybe it's off the bottom, so I want to move it sideways, I think that way. That's it.
Oh, there it is.
Oh, it's going to keep in the X values. Okay, now we've got the new parabola coming.
Now we're on new. Yes, shall I? Do you want me to reset it?
That's fine, just find new parabola. Okay. That shows you the effect of, just shifting it over, so it gets shifted. It's the
Yeah.
same.
Well, and of course you could draw a sign and cars and then shift one into the other.
Yeah.
and things. I mean, I think it's really powerful.
So the next one, you were just like tapping.
That was a PowerPoint.
You're not in.
No, this is a separate piece of software. But the PowerPoint was
Yeah.
just, I don't know why you double click to advance, but you
Right.
do. It's this thing of.
Come in.
Yes, yeah, it was a bit. Plus I ran through the slides before you got here. They're not. You wrote a book. I think it's how round is your circle, and that has a lot of drilling a square hole and things like that.
Right.
He's really fun. I've got these. Well, he gives them out, and I've left them at home now actually. But they're irregular solids of constant weight, and he gives you 3 of them.
Right.
So you put them down, you put the book on top of them, and it rolls completely straight. But what you've got is not. It's a funny shape. Do you understand?
Yeah.
So it's like coins. Coins are of constant weight, so they roll down
Yes.
vending machines.
Yeah.
But they're not often circles, or
Yeah.
not always circles.
Yeah. Okay.
It's kind of neat. But there's some sort of more complex stuff. And the other thing is there's the GeoGebra website itself has some good stuff. I was quite fond of the ladder down the wall. This is one that Chris showed us as well. I don't think this is quite the same. He had one where he had a cat sitting halfway down the ladder, and what path does the cat take as the ladder slides down the wall?
Right.
Things like this, which are quite interesting.
Assuming the cat doesn't jump off.
Yes. And then these are the sales resources. The line of best fit I showed you.
The line of best is very nice, isn't it?
There's also the gradient one. So once you, have we go? Once you move the 2 pencils to draw the gradient to a point.
That's nice saying.
So then I
That's
can
my
actually know
value.
this one as well, but if you click show gradient, okay.
Okay. Can we get one there? And the gradient one. Oh, you should click those.
I don't know if I should then turn off the... Oh, I see that.
Okay, I think you need
Yeah.
one of the selected points is not the bits in between. Yeah, okay.
Yeah, I see.